Many drugs and toxic agents act as enzyme inhibitors. Therefore, enzyme inhibition is an essential function to all animals. Enzymes are the biological catalysts which are able of speeding up the reactions. Where inhibitors are the molecule structures which are able of slowing down or stopping the biological reactions. There are various enzymatic inhibitors, and according to their main function, we can divide them into three groups. There are competitive inhibitors, non-competitive inhibitors, and uncompetitive inhibitors.
There are two main types of enzyme inhibitors, such as reversible inhibitors and irreversible inhibitors. Reversible inhibitors bind to enzymes through weak non-covalent bonds, such as hydrogen bonds, ionic bonds, and hydrophobic interactions. Because reversible inhibitors do not form any chemical reactions with the enzyme, they are formed rapidly and can be easily removed. Thus, the enzyme and inhibitor complex is rapidly dissociated in contrast to irreversible inhibition. Reversible inhibitors can be divided as three types of inhibitors: competitive inhibitors, uncompetitive inhibitors, and non-competitive inhibitors. Irreversible inhibition. Irreversible inhibitors bind to enzymes through tight covalent bonds or non-covalent bonds, so they permanently remove enzymes' catalytic activity. They are formed very slowly and can't be easily removed because it has become tightly bound to the enzyme. Aspirin is such an example for this irreversible inhibition. Aspirin is an irreversible inhibitor of the enzyme cyclooxygenase and thromboxane synthase. Aspirin at low doses inhibits enzyme cyclooxygenase in the platelets only.
Once in the bloodstream, cyanide forms a stable complex with the enzyme cytochrome oxidase, which promotes the transfer of electrons in the mitochondria during the synthesis of ATP. Cyanide acts as a non-competitive inhibitor, which binds irreversibly where it binds strongly to the enzyme. It does not allow the enzyme to bind with its substrate. So, without cytochrome oxidase, there will be lack of oxygen in blood. This is what we called hypoxia. The lack of available oxygen causes a shift from aerobic to anaerobic metabolism, leading to the accumulation of lactate in blood. The combined effect of hypoxia and lactate acidosis is depression of the central nervous system that can result in respiratory arrest and death.
The competitive inhibitors and the substrate are structurally related. They compete for the active site of the enzymes. They bind at the active site of the enzyme and they form enzyme inhibitor complex. They prevent the substrate from binding the active site. These lineweaver plots are a useful tool for distinguishing different types of inhibitors. These competitive inhibitors decrease the affinity of the enzyme for the substrate. As a result, the Km value increases. The effect of this inhibition can be overcome by increasing the concentration of the substrate. Increased concentration of the substrate will result in more products. In the presence of competitive inhibitor, the value of Vmax is unchanged because Vmax is the rate at high concentration of substrate.
In uncompetitive inhibition, the inhibitor binds to the enzyme substrate complex to a different site of the enzyme after binding with the substrate. As a result, the maximum reaction rate cannot be attained even at high substrate concentration. The Km value is also lowered and becoming more smaller at more inhibitor presence.
The inhibitor and the substrate has no structural relationship. The inhibitor binds at different site from the substrate. It works by either modifying the substrate active site or prevent the reaction from taking place. So increasing the concentration of substrate would not have an effect on this enzyme. In the presence of non-competitive inhibitors, the value of Vmax is lowered. This is because the inhibitor attaches itself to a side group in the protein chain, and this attachment causes a change in the tertiary structure of the enzyme. This in turn causes a conformational change in the active site of the enzyme. So the substrate can no longer bind to the active site. The non-competitive inhibition do not influence the Km value. So the Km value remains unchanged.
As we summarize, enzymes can be inhibited by specific molecules called inhibitors. Inhibition can be happened either reversibly or irreversibly. Inhibition is clinically important as many toxics and drugs act as inhibitors. There are three types of inhibitors: competitive, non-competitive, and uncompetitive. Competitive inhibition can be overcome by increasing the substrate concentration, but non-competitive and uncompetitive inhibition cannot be overcome by increasing the substrate concentration.